Bismillahirrahmanirrahim. So, starting with the second part of this series of three LCFs. So, basically, the first one was the calculation of sample size. The second one is about the t-test and pair t-test. So, one sample t-test and pair t-test. And the third one will be about the chi-square test. So, actually, we had two LCFs on one sample t-test and pair t-test. But we'll try to cover them in a single video, inshallah. So, if you can recall, we did study about z-test last year. So, what was the need for t-test over here? Let's see. So, basically, in z-test, the population standard deviation must be known, and the sample size should be more than 30. So, there are two characteristics of z-test. The population standard deviation must be known and sample size should be greater than 30. But what if the sample size is lesser than 30 and the population standard deviation is unknown? So in this case, we'll use the t-test. So let's see what is a t-test. So these are similarities between z-test and t-test. These are differences between z-test and t-test. If you want to go over them, you can. Okay. So there is something called the degrees of freedom, and we'll see them in all the formulas pertaining to the t-test. So we did not see this thing before, but now we are going to see them. So degrees of freedom measure the quantity of information available in one's data that can be used in estimating the population's variance. Variance is given by sigma square or the square of the standard deviation. So degrees of freedom will have different formulas and different type of t-tests. So basically, even if you don't understand what degrees of freedom is, because it's actually a quite complex concept, there is no need to understand basically what degrees of freedom is particularly, but you can explain it in different scenarios using different formulas. So basically, degree of freedom, if someone asks you the definition, then this is the definition of degrees of freedom, but the formula for degrees of freedom will vary from case to case. So basically, degrees of freedom measure the quantity of information available in one's data that can be used in estimating the population's variance. Okay, so it's basically the quantity of information which is used to estimate the population's variance. So let's move on. So in short, if the population standard deviation sigma is known and the sample size exceeds 30, we are supposed to continue with z-test. Otherwise, we'll use the t-test. So if the standard deviation is unknown and the sample size is less than 30, then we'll use the t-test. So how do we use the t-distribution? So normally we have a normal distribution. So we'll have for applying the concept of t-test, first we'll have to convert the value of normal distribution into a t-distribution. It's something called the t-distribution. And how do we do that? So any normal distribution x can be transformed to its value in t-distribution. Simply how? By using this formula. So let's see what each one of these variables means. The t is the value of x in case of t-distribution. So normally something is x, but when we are going to use it in t-test, we have to convert it into something called t. So to convert the value of x into t, we'll use this formula. So we'll place the value of x in place of x. So it will be given in the question. Mu is the mean. So mu, so x minus mu divided by sigma is the standard deviation and n is the sample size. So under root of n. This value of t-distribution is used while performing various t-tests. So basically, before we start performing a t-test, we have to convert the value of x into the value of t. So basically, we'll use this formula to convert the value of x into the value of t. So before we go on to solve some examples, let's see how do we classify t-tests. So t-tests, basically we have two major categories of t-tests: one sample t-test and two sample t-tests. Then in two sample t-tests, we have the dependent two samples and the independent two samples. And further, in the independent two samples, we'll have two independent samples which have the same variance, and two independent samples which have the different variance. So if you can recall, variance is the square of standard deviation. Okay. So in all types of t-tests, whether it's one sample or two dependent samples or two independent samples with the same variance or two independent samples with different variance, we'll calculate both estimation and hypothesis testing depending on the question. Whatever the question asks us, we'll have to calculate it. So if it asks us about estimating the population mean, we'll estimate the population mean in that scenario. If it asks us to perform hypothesis testing, we'll perform hypothesis testing. So for each one of them, this one, this one, this one, this one, this one, we can perform both of them. So we'll see we have various steps and formulas to calculate them. So let's see. So first we'll discuss one sample t-test and pair dependent sample t-test. One sample t-test and two sample but dependent one. And then in the next section, in this same video, we'll discuss four types of paired independent sample t-test. So we'll discuss paired independent sample t-test when the variance is same and paired independent sample t-test when the variance is different. So now let's start with single sample t-test. So in this first section, we'll cover one sample t-test and paired dependent sample t-test. So now let's begin with single sample t-test. So question, what will be the two things that we'll learn in the single sample t-test? Estimation, hypothesis testing. As discussed before, in all of them, in one sample t-test, we'll discuss estimation as well as hypothesis testing. In paired dependent sample t-test, we'll discuss estimation as well as hypothesis testing. In paired independent sample t-test with the same variance, we'll discuss both hypothesis testing and estimation. In the paired independent sample t-test with different variance, we'll discuss both hypothesis testing and estimation. Okay, so starting. So we'll begin with single sample t-test, and then we'll have to perform both estimation as well as hypothesis testing. So first of all, we'll learn the formulas which are involved. So one of the formulas that we have already discussed over here, this will be used while performing hypothesis testing. So for now, just forget it because we'll start off with estimation. So in estimation, we have an interval which is called the confidence interval, which we'll have to calculate, and we actually say that the mean lies within that interval. So what is the formula used when doing interval estimation in single sample t-test? So confidence interval is equal to x bar plus minus t alpha by 2 into s, which is this s, standard deviation, divided by under root n. So now let's see what we have got over here. So Ci is the confidence interval, x bar is the sample mean, which will be there in the question, t alpha by 2, so this thing. So t alpha by 2, how it's calculated? So it is calculated using the t table. So if you recall, we were calculating something called z alpha by 2 previously. So here we have to calculate t alpha by 2, and t alpha by 2 is calculated very easily. We'll see how we can do that. So it's actually very easy. So t alpha by 2 is calculated using t table. So we need two things to calculate the value of t alpha by 2. So we need the value of degrees of freedom and half of level of confidence as described below. Okay, so we'll discuss it. So since it's alpha by 2 and alpha is the level of confidence as already discussed in the previous video. So alpha by 2, so we'll have to divide by 2 and then look up its value in the t table. So, and then we have something in which we have s divided by under root n. So s is the standard deviation and n is the sample size. So standard deviation, so in t-test the standard deviation of the population is unknown, but we do know the standard deviation of the sample. So s denotes the standard deviation of the sample, whereas sigma denotes the standard deviation of the population. So since we don't know the sigma, because sigma is the standard deviation of population, we are performing the t-test. So we do know the standard deviation of the sample, which is s. So s divided by under root n. So this thing as a set is called the standard error. Okay, so let's see what we have to do next. So this is how confidence interval is calculated. So this is all. So the thing that we have to learn over here is how are we supposed to calculate T alpha by 2, and I'll show you in a moment how we do that. So let's see. So if you recall, we had something called the Z table, but over here, because it's not Z test, it's the T test, so we have the T table. How do we calculate something from the T table? So basically we need to have degrees of freedom, and then we need to have the value of alpha, which is the level of confidence, level of significance. So over here, and half of the level of significance, not the level of confidence, rather it is the level of significance, because alpha is the level of significance. So let's see. If we have to calculate T alpha by 2, what we'll do is we'll go to our T table and we'll find out the value, whichever value we are having for the degrees of freedom, we'll locate it over here. So let's say we have 5, and then for alpha we have the value, suppose we have the value 0.05, but since we are going to calculate T alpha by 2, so first we'll have to divide 0.05 divided by 2, so 0.05 divided by 2 is 0.025, so we'll have degree of freedom 5 and alpha 0.025, and the value that we are going to get of T alpha by 2 is 2.571, which is the place of intersection of both of them. So that's how we calculate T alpha by 2. Now moving back, this is how over here, this is how we do interval estimation in single sample t-test using this formula. We'll just simply plug in the values, and we'll see in an example later on, inshallah, that how we do that. So basically we have to calculate the value of confidence interval. X bar is the sample mean, T alpha by 2 is calculated as I've already shown, and S over under root n is the standard error, and S is the standard deviation of the sample, not the population but of the sample, and under root n is the sample under root of the sample size, because n is the sample size. Okay, so what's next? So now we have to perform hypothesis testing in single sample t-test. So as we have already discussed, that for each and every one of them we will perform these two things, estimation as well as hypothesis testing. So we did estimation by calculating confidence interval. Now we'll move on to hypothesis testing. So let's see. So what are the steps for doing hypothesis testing in single sample t-test? So first we have to state the null and alternative hypothesis according to the situation. So we can have either one of these situations, one-sided test, and two-sided test. So basically we have two kinds of one-sided test and one two-sided test. We have already discussed it in CHSME in part 1 in much more detail, so you can refer back to it. So basically we can have a right tail test, a left tail test, and a double tail test. So it all depends on the question that we are being asked. So if the question wants us to see only one tail, like is mu greater than mu naught, if this is the question, then this becomes our alternate hypothesis. So is mu greater than mu naught, this is our alternate hypothesis. If the question states is mu less than mu naught, so this becomes our alternate hypothesis, is mu less than mu naught. And if the question asks is mu equal to mu naught, then in this case especially we'll have to make an alternative hypothesis which states that mu is not equal to mu naught. So if the question has anything like equal to or not equal to, in that case we have a two-side t-test, while if the question asks us greater or lesser, then we have a single side t-test. So this is how we have three kinds of t-tests: right-tailed, left-tailed and double-tailed. Then the basically the alternative hypothesis is derived using the question, and then we have the null hypothesis, which is opposite of that of the alternative hypothesis. So first we'll have to state the null and alternative hypothesis in this way, either one of them. Okay, so then the second step is state the level of significance, not the level of confidence, rather the level of significance. Level of significance is alpha, and normally it will be given in the question. So then the third step is to calculate the calculated value using the following formula. So if you recall, in the start of this section we discussed a formula, this formula t is equal to x minus mu s divided by under root n. So this is the formula that we are going to use now. So we have already discussed this formula, but let's go over it again. T is value of x in case of t distribution. X is the value given in the question. Mu is the mean. This is the standard deviation of the population, but since in t-test we are not given with standard deviation of the population, we denote it by s, and this is the standard deviation of the sample. But this is one of the characteristic of the t-test, that we do not have the standard deviation of the population. So we have s in the formula because s denotes the standard deviation of the sample, and n is the sample size. So we have under root n over here. Then first we'll have to calculate t calculated using this formula. Then there is another thing which is called the t tabulated, and this is found out using the t table. So what two things we need to find something in the t table? Number one is degrees of freedom, and number two is level of significance. So how do we do that? We'll go to the t table. We have already seen how we find out values in the t table, but let's see for ourselves. Here we are, degrees of freedom, and then the value of level of confidence. So we'll just find out the point of intersection of both of these things. So suppose we have degrees of freedom 10, and then the value of alpha is 0.01. So this is the point of intersection over here. So this is our t value. This is how we calculate the t calculated, the t tabulated, because we are using the table, so it's called the t tabulated. So let's go back. So now what we have to do, we either have to reject the null hypothesis or we fail to reject the null hypothesis. So how do we reject the null hypothesis? Reject null hypothesis if t calculated is greater than t alpha by 2. Okay, and this is in the case of a double-tailed t-test. In case of a right-tailed t-test, we reject the null hypothesis if t calculated is greater than t alpha. So t alpha by 2 is not used in this case, rather we use t alpha. In a left-tailed t-test, we reject the null hypothesis if t calculated is lesser than minus t alpha. So these are the three scenarios when we reject the null hypothesis. So basically we calculate both of these values, calculate t calculated, and then we find out t tabulated, and then we compare them. So let's see one of the examples which will make the things much more clear. So the average hemoglobin level of a normal woman is 13. The doctor at clinic A feels that the pregnant women coming to the clinic are mostly anemic. She takes a random sample of 25 pregnant women who have registered at the clinic and looks at their hemoglobin levels. The data is summarized below. Sample mean is x, so we get the value of x from here. X is 11.8, and this is given in the question. So sample standard deviation is s, and it's 2.6. Sample size is 25. Are the pregnant women coming to the clinic A anemic? That is the average hemoglobin of the pregnant women at clinic A less than that for normal women? So this is the question. let's see which type of null and alternative hypothesis are we going to make over here. So let's see. We had these three types. Is mu less than mu naught? So this is the type of hypothesis that we are going to use over here. This one, which is a left-tailed t-test, and then what will be the null hypothesis? Mu is greater than mu naught or equal to mu naught, and alternative hypothesis mu is less than mu naught. So let's see over here. Have we made the same harmony? Yes. Mu is greater than or equal to 13, or alternative hypothesis is mu is less than 13, and alpha, which is the level of significance, is 0.05. And then what we do is we use the same formula. T is equal to x bar minus mu, which is this formula. So we use this formula. T is equal to x bar minus mu divided by s over under root n. So x bar is 11.8, 13 is the mu, then we have 2.6 as the sample standard deviation, and under root 25 as the under root n value, which is the sample size, and then we calculate it. So it comes out to be minus 2.32. Now the next step. Okay, so now we either have to reject the null hypothesis or we fail to reject the null hypothesis. So let's see what we are supposed to do over here. So since we have already seen that this is a left-tailed t-test, why is this a left-tailed t-test? Because of the question. The question says, is the average hemoglobin of the pregnant woman at clinic A less than that for the normal woman? And we have already seen that if it's less than mu naught, then it's a left-tailed t-test. So this is a left-tailed t-test, and we have to see now that when are we going to reject the null hypothesis. So we have already looked at the formulas which we'll use to reject the null hypothesis. So in a double-tailed t-test we use this formula, in a right-tailed t-test we use this formula, and in a left-tailed t-test we use this formula. So since it's a left-tailed t-test in this case, we'll use this formula, and this formula states that T calculated reject the null hypothesis if T calculated is lesser than minus T tabulated or minus T alpha. So let's see. So T calculated should be rejected if it's less than minus T alpha. So alpha is the level of significance. So how are we going to do that? So basically, let's see. If we have to find out the value of T alpha or the T tabulated, T alpha and T tabulated are the same things. So how do we do that? We need two values to calculate to find out the values of T tabulated or T alpha. So what things do we need? So basically we need degrees of freedom and we need the value of alpha. So how do we do that? First of all, degrees of freedom. So there is a specific formula for calculating degrees of freedom, and this formula is specific for calculating degrees of freedom in case of single sample t-test. So this formula for degrees of freedom is specific for single sample t-test, and this formula is given over here. So degrees of freedom is equal to n minus 1, where n is the sample size. So n minus 1. So the sample size n in this case was 25. So 25 minus 1 is 24. So we have the degrees of freedom 24. Then alpha. The value of alpha will be given there in the question as the level of significance, and in this case the level of significance is 0.05, as we have already used this value of alpha over here, 0.05. It will be given in the question. So we have 0.05 as the level of significance, we have 24 as the degrees of freedom. So now what we have to do is to find out the value of T tabulated. So what we'll do, we'll go, we have these two values, so let's write them over here. Alpha is equal to 0.05 and degrees of freedom is equal to 24. So let's go to our T table and let's see what we have got over here. So we are going to find out the value of T tabulated using the T table. So over here, the value of alpha is 0.05. So here we have 0.05, and degrees of freedom is 24. So here it is 24. So 0.05. 0.05 is the second column, and 24 is over here. So the value of alpha that we, the value of t tabulated is 1.711. So let's go back. 1.711 is the value. Let's see, do we have the same value in the example too? Yes, 1.711, we have the same value. So what now we have to do, we have to check if t calculated is lesser than minus 1.711. So what was the value of t calculated? We calculated over here minus 2.32. So minus 2.32 is it lesser than minus 1.711? Yes, obviously it is lesser. So this means that we are going to reject the null hypothesis, because we had to reject the null hypothesis if t calculated, which is this value which we have calculated using this formula, this one, which is the same formula as this one. This is t calculated. If it was less than minus t tabulated, which we found out using the t table. So if it's less than minus t tabulated, minus is basically we multiply the value that we find out in the t table by minus 1, then we see. So in this case minus 2.32 is obviously less than minus 1.711, so we reject the null hypothesis. So therefore we reject the null hypothesis at 5% significance level. Thus what we find out is there is sufficient evidence to conclude that the average hemoglobin for pregnant women at clinic A is less than that for normal women. Why? Because we had these two hypotheses. The null hypothesis stated that mu is greater than or equal to 13, but since we reject this null hypothesis, we find out that this is the true situation, which means that mu is less than 13, and thus we conclude at 5% significance level. Why 5% significance level? Because we used 0.05 or 5%. 5% is 0.05 as our level of significance in this case, as the alpha value. So this is how we do it. So that's it. Now we'll move on towards confidence interval. How we perform confidence interval in single sample t-test, and we'll use the formula that we have learned above to perform this example. So if you recall, if 95% confidence interval for mu needs to be calculated, let's see what we have to do. So we'll basically be using this formula over here, this one, which is for interval estimation. So let's see how we do that. So it's actually quite simple. 95% confidence interval for mu. So basically we'll take x is the value of value given in the question, which is 11.8. Let's see, here it is, sample mean 11.8, which is given in the question. So x is 11.8 plus minus t alpha by 2. We have already seen how we calculate t alpha by 2. So how do we do that? We basically see the value of alpha. So this is 95% confidence interval. This definitely means, so what's the relationship between the level of confidence and level of significance? So basically, let's see. So if we subtract the level of confidence from 100, if it's in percentages, we get the value of level of significance, which is over here is 5% or 0.05, because 5% means 5 divided by 100, which comes out to be 0.05. So now we have to calculate t alpha by 2, because the formula asks us to do so. So how will we do that? T alpha by 2. So basically for calculating alpha by 2, we need two things, as we have already discussed. What are those two things? We need degrees of freedom, which in this case is, for specifically for single sample t-test, we'll have to calculate degrees of freedom using this formula, n minus 1, and over here n is 25 minus 1, it is equal to 24. And then the second thing that we need over here is the value of alpha. So alpha is equal to 0.05, but see over here we have to calculate t alpha by 2. So basically alpha is 0.05, alpha by 2 is equal to 0.05 divided by 2, which is equal to 0.025. So degrees of freedom, which is 24, and alpha by 2 is 0.025. We'll go to the z table, the t table. Let's see. Degrees of freedom is 24 over here, and alpha is 0.025, which is the third column. So let's see. So the value of t is 2.064. Let's see, have we calculated it correctly? And .064, so it's correct. So 11.8 plus minus 2.064, and then S is the standard deviation given in the question. So standard deviation of the sample which is there in the question, which is 2.6, and so S is 2.6 and N is under root N. So the value of N is 5, so under root of the value of N is 25, so the under root of 25 is 5 is 25. So here we just simply calculate it by multiplying both of them. So 2.064 and 2.052, and we get this value. So now what we'll have to do is 11.8 plus minus 1.073. So we can so we'll first subtract 1.073 from 11.8, and then we'll get 10.72, and then we'll add it to this 11.8 plus 1.073, and then we'll get the value of 12.87. So this is how it's done. So the value of mu will fall in between 10.72 and 11.87. This we can say with 95% confidence. Okay, so now that we are done with single sample t-test, so let's move on to the two dependent sample t-test. So as you can recall over here, we had t-test single sample and two samples, and in two samples we had further two classifications, dependent and independent. So now we are done with one sample t-test. Now we'll move on to the two sample t-test, which with the dependent classification. So let's see over here. Okay, so moving on, we are now going to perform both hypothesis testing as well as confidence interval estimation on dependent samples t-test. So we have two dependent samples t-tests over here. So what kind of samples are considered dependent samples? So when means are computed for the same group of people at two different points in time, before and after the intervention. So if we have a group of people and we perform an intervention upon them, so it can be anything ranging from any sort of drug or anything like that. So basically we find out a mean of a particular parameter before, and then we find out the mean of a particular parameter after that intervention. And then we have a second situation where subjects in one group are paired to subjects in the second group on the basis of some attribute. So basically we have two different groups, but the people they have similar attributes, and that gets them paired up. So let's see how it works. So basically, first of all, we'll see the formula for interval estimation in dependent paired sample t-test. So first we saw both of these formulas for individual sample t-test or single sample t-test. So now we have formulas for paired sample t-test dependent. So let's see, confidence interval, it is given by x bar subscript t, which is the mean of the differences of mean of sample. So basically we have two samples, either one is before or after, or there are two populations which have certain characteristics similar. So we have these two individual means, and then we calculate a mean of those means. So basically we add them up and divide by 2. So this is how it works. So Ci is the confidence interval, Xt is the mean of the differences of mean of sample. So basically we'll have to calculate the difference of both of them, and then we'll have to divide by 2. So this is the mean of the differences of sample mean. But we'll see in detail how it works. Then so basically x under a subscript d, x bar and subscript d is equal to x bar 1 minus x bar 2. So basically we have the difference of both of the means. So next we have t alpha by 2. T alpha by 2 is calculated using the t table. We are absolutely clear how it is done because we have already discussed it twice before. So next we have the SD divided by under root ND, which is a standard error, that is standard deviation divided by the under root of number of pairs of sample. SD is given by this formula. So SD, what is SD? SD will usually be given in the question, so you most probably don't need to remember this formula, but if we have to calculate SD, this is how we do that. Now let's see the formula, and the various parts of this formula will be clear as we move on. So this is how it works. So basically confidence interval xt is calculated in this way. Then we have t alpha by 2. We already know how to we calculate t alpha by 2. Then we have st over under root nd. Nd is the sample size. St is the standard deviation divided by the under root of number of pairs of samples. So this is how it works. But normally ST is given in the question. If not, then we'll have to calculate it using this formula. We can see later on how it works. So moving on. So now we have done interval estimation. The formula for interval estimation, we'll cover both the examples later on. So once we are done with interval estimation, we'll move on to hypothesis testing. So what is the formula used when doing hypothesis testing independent paired sample t-test? So this was a typo over here, so please correct it. It is hypothesis testing. So state the null hypothesis, which will always state that there is no difference between the two means. So null hypothesis in case of two dependent samples t-test will always be the same. So this is h naught is equal to, h naught states that mu1 is equal to mu2. Next we have the alternative hypothesis. The alternative hypothesis can be either one of the three. First one being the two-tailed test, which states H alternative states that mu1 is not equal to mu2. H alternative states that mu1 is greater than mu2, and H alternative states that mu1 is lesser than mu2. Whenever it's lesser than mu2, then it's a left-sided t-tailed test. When it's greater, then it's right-sided t-tailed test, and when it's not equal, then it's two-tailed t-test. So now moving on. State the level of significance alpha given in the question. Alpha will always be there in the question, or we can find it out using the level of confidence. How we do that we have already discussed. So basically, if the level of confidence is 95, we simply 95%, we simply subtract it from 95 from 100. So 100 minus 95% is 5%. So the value of alpha is either 5% or 0.05. So in simple numerical terms, it is 0.05. In percentage, it is 5%. So calculate the test statistic t calculated using the formula this one. So t calculated is found out using this formula. So what is this formula? T is the test statistic, d bar. So d bar is mean of the differences of mean of sample 1 and 2. So d bar is equal to x bar 1 minus x bar 2. And then this thing SD over under root ND is the standard error, that is standard deviation divided by the under root of the number of pairs of sample. SD is given by this thing. So normally, as we have already discussed, SD will usually be given in the question, so we most probably won't have to remember this formula. Okay, so using this formula, what we calculate is the test statistic. So it is also called the t calculated. Now, as always, we'll have to find something which is called the T tabulated. So how we are supposed to do that? Look at the T tabulated and the T table using. We need two things to calculate T tabulated. So alpha and degrees of freedom. Alpha in a single tail test left or right, or alpha by 2 in a double tail test. So if the test is a two tail test, we'll have to use alpha by 2. If it's a single tail test, we'll have to use alpha. And then degrees of freedom given by the formula, degrees of freedom is equal to nd minus 1, where nd is the number of sample pairs. So here we are not using the term n, which is the sample size, rather we are using the term nd, which is the sample number of sample pairs. So basically the total size of sample is divided by 2, which gives us the value of nd, which is number of sample pairs, or if it's given directly, so we use the value of nd directly. So next, then we'll have to compare T calculated, which is found out using this formula, with T tabulated, which is found out using this thing. So how do we do that? T calculated, if it's not equal to 2, reject the null hypothesis. If in a two-sided t-test, again T calculated is not equal to T tabulated, it gets rejected, the null hypothesis gets rejected. In a right-sided t-test, if T calculated is more than T tabulated, it gets rejected. And in a left-sided t-test, if T calculated is less than T tabulated, the null hypothesis gets rejected. So you'll have to remember about situations where we have to reject the null hypothesis. So let's see an example on how to perform hypothesis testing on a dependent paired sample t-test.
Okay, so let's see this example. So over here, insurance adjusters are concerned about the high estimates they are receiving from Garage 1 for auto repairs compared to Garage 2. To verify their suspicions, each of the 15 cars recently involved in an accident was taken to both garages for separate estimates of repair costs. We can make an inference about whether the estimates of two garages differ or not. So basically, we have these 15 cars over here, then we have these two garages, and these 15 cars were involved in accidents, and then they were taken first to this garage, and after another accident they were taken to this garage. So basically the cars are the same, so the two sets of samples are linked because the cars are the same. So this means that which kind of t-test we are going to use? Definitely we are going to use it's over here. So two dependent sample t-tests, because the samples are dependent over each other because they were the same cars. So let's see. So these are the cars, these are the 15 cars that we had. So this is the repair cost at Garage 1, this is the repair cost at Garage 2, and this is their difference. So now t-test for two independent samples is not appropriate over here because the adjusters obtained a measurement from both garages for each car rather than having a random sample of 15 cars examined by Garage 1 and a second sample of cars examined by Garage 2. So basically what we are saying over here is that t-test for two independent samples is not appropriate over here, rather we'll use t-test for two dependent samples because the same cars had the estimates taken from both of these garages. So now insurance adjusters, they were interested in the difference of estimates between the garages. We calculate the difference between the two garages for each car, so it is calculated like this: t is equal to x1 minus x2. So it's like this. So this is the difference, this is the difference, this is the difference, this is the difference. So we actually subtract this one, Garage 2 from Garage 1, and then we get these values. So this is how it is done. Now suppose mu d is the population mean of the difference, then mu d is equal to mu1 minus mu2. So if we calculate the mean of all these values, then the answer will be related to both of these values in a way that if we calculate the mean for garage 1 and then we calculate the mean for garage 2 and we subtract the mean for garage 2 from garage 1, we'll get the same answer because these values are actually representing the difference of these two garages, so their mean will also be representing the difference of these two garages. So this is what this formula is saying over here. So where mu1 and mu2 are the population means for the two garages. So we'll then calculate the test statistic, also known as T, calculated using this formula. So we had a different formula once we were calculating T test for a single sample, but over here, since it is the case of a T test with two dependent samples, so we use this formula. In case SD, we have this thing over here, this thing in the formula, SD is known in the above formula. It will be calculated individually by the following formula in case it is unknown. However, the value of SD is usually given in the question, so we have already discussed that normally they'll provide us the value of SD. However, if it's not given, then we'll have to use this formula. Okay, so looking back at the formula, we have this D and then we have mu D. So basically mu D represents our null hypothesis. So as shown over here, mu D is this. So according to the null hypothesis states that mu D should be 0. That is, that there is no difference between the prices offered by both of those garages. So every time we do a t-test of two dependent samples, the null hypothesis is always this, that mu D is equal to 0. So we consider mu D is equal to 0. So D bar minus mu D is always 0, so we can exclude this value, but we always consider it in the formula. So then the alternative hypothesis states that mu D is greater than 0. That it's not 0, but the null hypothesis states that mu D is equal to 0, so we'll always put the value of 0 over here. Okay, then D is 0.61. So how do we calculate D bar? So D bar is what we are getting from the samples that we are having. So basically, if we calculate the mean for this population and the mean for this population, and then we subtract the mean for garage 2 from garage 1, and the answer that we get is D bar. Or in other words, if we individually have their differences, like we subtract garage 1 minus garage 2, take all these values, and then we find out the mean for these values, then that the answer that we get over here is also D bar. But the thing about which we must be careful is that we should make it a habit that either we are supposed to subtract 2 from 1 or 1 from 2. So basically, by convention, we normally subtract 2 from 1. So even when we are subtracting means, then we must subtract 2 from 1. So mu 2 minus mu 1. So that's how it's done. So if we are using this convention like mu 1 minus mu 2, then we must stick to it. So both of them, they are correct, but we should stick to one of them. So we can't simply change the way we are working in the middle of a question. So just pick one of these types and then just stick to it. Okay, so next, so the alpha will be given in the question, which is 0.05. This is also called the level of significance. So let's see how we go about this question. So over here, D is 0.61. According to the null hypothesis, mu D should be 0. So this mu D is 0. So minus 0 is nothing. So 0.61. D is given in the D is calculated as I have already told you, that you'll have to subtract the mean for these values from this value, or the mean for this value from this value. So here we are, 0.61 is the answer. So then we have to divide by SD. SD is normally given in the question, otherwise we'll have to use this formula to calculate it, but normally it will be given in the question. So 0.394 is the standard deviation for this pair, and then we have the number of pairs ND. This is actually ND. So ND is 15. So actually we don't count the individual incidences, otherwise we'll have 30 over here because we have 15 cars over here, 15 over here. But we actually count the pairs in dependent sample t-test. So the number of pairs is 15. So we calculate it and we get 6 as our answer. So this value that we get over here, it is t calculated. Now up next we'll have to find another value which is t tabulated. Okay, so let's see how we find out the value for t tabulated. So we need two things for finding out the value for t tabulated. So already we have found out the value for t calculated using this formula. Now t tabulated is found out using the value for alpha and degrees of freedom. So the alpha will be given in the question, like over here we have 0.05, which is the value for alpha. And degrees of freedom for two dependent samples t-test, degrees of freedom is calculated by subtracting 1 from the pair of samples. So we had 15 pair of sample and we subtract 1, so we get 14. So now we have alpha as 0.05 because it was there in the question, 0.05, and we have degrees of freedom which is 14. So the ND, so basically the number of pairs of samples we are having minus 1, so we have 15 pairs minus 1, it is 14. So let's see, we have 0.05 as alpha and degree of freedom is 14. So we'll go to a t table, we'll look at 0.05 over here and 14. So the answer is 1.761. So coming back, the answer is 1.761. So now we have these two values. We have the value for t calculated, which is 6. Then we have the value for t tabulated, which is 1.761. Now we are supposed to compare both of these values, as we can easily recall that in all the hypothesis testing we are actually comparing the value of t calculated and t tabulated in the end to find out whether we are supposed to reject the null hypothesis or not. So if you can recall, this is a right-tailed test. So we have already discussed over here that in a right-sided test we reject the null hypothesis when t calculated is greater than t tabulated. So let's see. T calculated, it's 6, it is obviously greater than 1.76, which is t tabulated, so we reject the null hypothesis. Thus, since t calculated is greater than 1.761, we reject the null hypothesis at 5% significance level because alpha is 0.05, so in percentage we multiply it by 100, we get 5%. So 5% significance level. Hence we conclude that the mean repair estimate for garage 1 is greater than that for garage 2, because this was the alternative hypothesis that we had to prove. So this is it. Now moving on to another example. Okay, so we have another example for hypothesis testing on a dependent paired sample t-test. We will not be covering any examples on estimation in case of a pair of dependent sample t-test, but it's quite obvious how we are supposed to perform it. Simply plug in the values in the formulas given above, as we have already discussed. So that's how it's done. But hypothesis testing is a bit more difficult or a bit more complex, so we'll just be discussing it. So another example on hypothesis testing: to determine whether a person's physical condition improves after taking up jogging, an investigator obtains maximum volume of oxygen uptake values before the subject starts jogging and again after 6 months. The following data lists the value for VO2 uptake for 10 randomly selected joggers. We want to know whether the jogging has been effective in improving physical condition as measured by the change in volume of oxygen uptake over time. So we have these 10 cases, before jogging, after jogging, and this is the difference. After minus before, they have used this thing, so we must stick to it throughout the question. Okay, so now we have these 10 cases. So first we'll have to decide whether these cases are independent samples or dependent samples. So obviously they're dependent samples because these 10 cases are having a before and then after test, so the people remain the same. So basically since we have a single set of 10 people who are having a before and an after situation, so therefore this is a dependent sample t-test. So the solution over here, so the sample mean of difference is 12.27, which is d bar. Sample standard deviation of differences st is 1.203. It will be given in the question. The hypothesis of interest is mu d is equal to 0. So I have already told you that mu d will always be equal to 0 for null hypothesis in case of paired dependent sample t-test. And alternative hypothesis can take three forms. So over here we have a right side t-test that mu d is greater than 0. It could have been mu d is lesser than 0 or anything like that. Okay, and then alpha is 0.05. It will be given in the question. So first we'll have to calculate the value of t calculated. So if we recall the formula over here, we have this formula. So d bar minus mu d. So we know that mu d is equal to 0 according to null hypothesis, so we place the value of 0 over here. Then we have d bar. So what we place in case of d bar, this thing 12.27, so we place 12.27 over here. Then what we have to do, we'll have to look at the denominator of the formula. So it is SD divided by under root n. So SD, which is 1.203, if it's not given in the question, then we'll have to use this formula to calculate it, but normally it is given there in the question. So SD, which is 1.203 divided by under root 10. So basically we don't take the number of samples, like we don't take them individually like 10 over here and 10 over here and we place the value of 20 over here. Rather we place the value of 10 over here because we are actually dealing with pair of sample in two dependent sample t-test. So if we calculate it, the value is 32.25. So this is the value of t calculated. We know that next we will have to calculate the value of t tabulated. As always, we'll need two things for t tabulated. For degrees of freedom, we'll subtract 1 from the number of pairs of samples that we are having. So 10 pairs minus 1 is equal to 9. And then we'll have the value of alpha, which is 0.05. So now we'll go towards the t table and see the corresponding t value. So we'll have to see the corresponding t value for 0.05 and 9. So let's go to the t table. 0.05 is over here, 9 is over here, they intersect over here. So it's 1.833. Let's see. And here we have our t tabulated, which is 1.833. Okay, so up next we'll have to compare t calculated with t tabulated. So t calculated is this value that we used, that we found out using this formula over here, and then we have t tabulated, which we found out using degrees of freedom and level of significance and looking it up in the t table. So what we have to do over here, we have to compare them. So for this we must know that this is a right side t-test. Why is it a right side t-test? Because the alternative hypothesis states that mu d is greater than 0, and we have already discussed that whenever we have an alternative claim that mu d is greater than 0, then this is a right side t-test. So let's see how we are going to compare them. So we have these rules. So this is mu d, so is greater than 0, which is a right side t-test. So for that we'll have to compare them using this formula. If t calculated is greater than t tabulated, we reject the null hypothesis. So let's go back and see. T calculated is 32.25, t tabulated is 1.833, which obviously t calculated is much greater than t tabulated. Thus we reject the null hypothesis. Since t calculated is greater than 1.833, we reject the null hypothesis at 5% significance level. So 5% significance level is because we use alpha is equal to 0.05 over here. So alpha is equal to 0.05. Alpha is also a level of significance. if you multiply 0.05 with 100, you get the value of 5, so 5%. So 5 at 5% significance level, hence we conclude that jogging increases a person's VO2 uptake, that is jogging has been effective, because the null hypothesis was that there is no difference whether you jog or not, but mu d is greater than 0 when someone jogs, which means that the difference is greater than 0, which means that there is an effect, and thus jogging is effective, and we have proved it. So this is the t table that we have been using to find out the value of t tabulated. Next we have t test for 2 independent sample case, but we'll take a break over here. We'll start it up. We'll start with this thing in the next video, inshallah. Thank you.